Hi, my name is Luke Nash and my colleagues are Lewis Challens and Matthew Lagaroth. We are Group 45 and this is the Manufacturing Automated Plant Safety System, or MAPS for short. We developed a prototype aimed at reducing the incidence of workplace-related hand and wrist injuries within the manufacturing sector. We have chosen to simulate a table saw with our prototype as they have a particularly bad safety record due to the nature of having to put your hands within close proximity of the blade. It is important to note that MAPS is designed to be integrated with existing saw braking technology such as the saw stop. The key functionality we have designed for is to trigger the braking mechanism and eliminate the hazard before an injury has occurred. Maddie will now go through some of the hardware necessary to achieve our functionality.
Thanks, Luke. Here we have the top side of our development board.
You will notice that the board has been painted a matte black. This is to absorb as much light as possible to reduce reflections picked up by the camera. Here we have our dual camera setup, supported by this L bracket. Cabling has been contained within this timber C channel for additional protection. The top camera here covers everything in the X and Y plane, along here, while the bottom camera covers everything in the X and Z plane. Here we have our calibration interface. You can connect to the top or the bottom camera, and here is our switch to simulate turning the blade on and off. Here we have the underside of our development board. In the center here we've got our LED lighting strip, which I can turn on and off. We've got two Raspberry Pi microprocessors, each managing a separate camera feed. This is to aid in significantly reducing the latency within the system. The Raspberry Pis are connected to a 12-volt relay panel redundancy system over here. This system is multi-purpose, and when integrated with a blade braking device, it will stop the blade in the event of either a software freeze or if power gets switched off to the Raspberry Pis. Over here, you can see all of our 230-volt hardware is segregated from the components on the outside of the board.
So each Raspberry Pi is running OpenCV computer vision software to track the user's hand based on color. So we can see we have Maddie's hand in the original image up here, and this is converted to an HSV red, green, blue color space. So as we do this, we can set the thresholds within these track bars here. So these set the maximum and minimum values for our HSV parameters, and allows us to focus in on the individual pixel colors that we're interested in. So all pixels within these thresholds are set to a 1 and outputted into this binary image down the bottom here. So we can see we're only interested in his hand, so we have a white outline of his hand in the bottom here. This lets us easily track the location of the hand as it moves across the screen.
I will now do a quick user demonstration. I have my orange safety gloves on and I'll now simulate cutting this block of timber. As you can see in the video feed, the camera is tracking my orange safety glove. Perimeter points are marked around the outside of the glove, and these trigger a relay for the camera when the perimeter point enters the exclusion zone marked in green. I'll now turn on the table saw. As you can see, the blade is now energized. I'll place my hand in a dangerous position because I'm not paying attention, and I'll pass the wood through the blade. As you can see, when my hand enters the exclusion zone, the blade is de-energized.